sir.
Good morning. I think all of you have our MS College chemistry material. Do you have? Do you have MS College chemistry material?
Yes, sir, we have.
In that material, please open
In
a
that
topic
material,
called
please open a topic.
whatever I am speaking is not there in the textbook for 11th class. It is there in a different topic. So today I am going to talk to you about stereoisomerism. Stereoisomerism is there in MS College material. Okay? Will you see? I will tell you the page numbers tomorrow. You can set yourself today if you want. Do you know we have discussed about isomerism? What are isomers? Different compounds with same molecular formula are called what? Isomers. Okay, sir? Isomers are how many types? Structural isomers. Second category is stereoisomers. Structural isomers differ in the bonding sequence of atoms. For example, if you have all the 4 carbons in a continuous chain, it is called ordinary butane. But if they are in 2 branches, one is having 3 carbons, one side chain, it is called isobutane. Normal butane and isobutane are called what, sir? Chain isomers. Do you remember the term? Chain isomers differ in the bonding sequence. Here carbon, 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 continuous. Here only 3 carbons are continuous. One carbon is again locked to 3 carbons. There is a tertiary carbon. Here this carbon is locked to only 1 carbon. This is locked maximum to 2 carbons. Such compounds which differ in the sequence in which atoms are bonded called structural isomers. There are so many variants in structural isomers as you remember. Chain isomers. Next one is chain isomerism. Next one is
functional isomers.
positional isomerism. Next one is
Functional isomerism.
functional isomerism. Next one is
Metamerism.
next one is.
Tautomerism.
Do you remember all these cases? Chain isomers. How many chain isomers pentane has? How many chain isomers hexane has?
5.
How many chain isomers heptane has?
6.
How many chain isomers octane has? How many chain
18,
isomers nonane has?
35.
How many chain isomers decane has? I think you remember them, right? What is the common name of this compound? Neopentane, isopentane. Neopentane has maximum branches. Isopentane has one branch. Can you see that?
Yes.
So we know all that, right?
Yes, sir.
Yes.
What is the relation between 2-chlorobutane and 1-chlorobutane? What type of isomer?
Position isomers.
Yeah, I think you have more clarity. I'm not going to revise the structural isomerism. You want me to revise structural isomerism now, or should we go ahead?
Yes.
Sir, tautomerism.
Okay, tautomerism is a special case. Compounds like ketones where they have a C that is sp2 hybridized locked to another sp2 hybridized atom through double bond. Two sp2 hybridized atoms linked through double bond are there. Now these are linked to sp3 atom with hydrogen. Notice auntie and boy are sp2 hybridized atoms having a double bond. Now auntie is also linked to a chutney that has hydrogen. Now what happens? The boy will take the pi electrons because oxygen is more electronegative. When boy is taking pi electrons, now carbon gets only 3 bonds. Yes or no? I will draw it for you again. Here auntie has taken the pi electrons. Now this carbon which is there in the central position got how many bonds, sir? How many bonds? Hello.
3.
Now this carbon is not a dirty rock to have 3 bonds. So the carbon will take the sigma electrons connecting neighboring carbon hydrogen to itself. I will draw everything once again to make the point clear. This is your acetone. Okay. Now the oxygen is taking pi electrons. When it took pi electrons, what happened? Oxygen got minus charge. What happened to the central carbon? What happened to central carbon, sir?
It lost one electron.
So it will take the neighboring CH electrons and convert into a double bond. So you will be getting like, where should I draw? Okay, I draw with this color. This hydrogen became plus. Now what happened? The carbon is happy because it got 4 bond, this also got 4 bond. Who is unhappy, sir? Who is unhappy in this lot? The H
Oxygen,
plus will
hydrogen.
combine with O minus. The H plus will combine with O minus so that you will be getting. Oh, let's go to black ink. This formula. From what? From this. This is called keto form. This is called in all form. Can you see how they got interconverted? What
Yes.
happened, sir? Thus, oxygen has 5 electrons. It got minus charge. The CH bonding electron has come out, and hydrogen itself got shifted to this. Yes or no? Because it got minus charge, it has taken energy. Can you see it very clearly, sir? Hello?
Yes, sir.
So a keto form or enol form, if you look at carefully, it has two sp2 hybridized atoms linked by double bond. In this case, auntie and boy. In this case, chutney and donkey. Two fellows must be linked by a double bond. Then the atom that has a double bond must have a neighboring atom like oxygen or nitrogen or carbon that has a hydrogen bond to it. They get interconverted. Can you see that really? These are sp2 hybridized. They are having a carbon that has hydrogen. These are sp2 hybridized. They have an oxygen that is sp3 hybridized and hydrogen. So that is a requirement for tautomerism to exist. Are we very clean? Hello.
Yes, sir.
Suppose here you look, everybody has a double bond. Can you show tautomerism? Yes or no?
No, sir.
No. Why no? Every atom is making a double bond somewhere or other. If everybody is making a double bond, there is somebody who is making only a bond with the carbon and hydrogen, and there should be somebody who is making only single bonds. It is not having. Yes or no? All atoms are sp2 hybridized. No tautomerism. Can it have tautomerism? Can it have tautomerism?
No.
No, because all are sp3 hybridized. If there are all ladies in a room, they can't have children, even if they try. If they have all gents in one room, they can't have children, even if they try. You require a combination. Yes or no? Yes or no?
Yes, sir.
But even in that combination, immediately you can't get a child tomorrow morning. You have to wait. You have to put in effort and wait. Agreed? So for tautomerism to
Yes,
exist, the tautomers exist only if there are sp2 hybridized atom linked through double bond, which are connected to sp3 hybrid atoms having hydrogen. And for one tautomeric form to be converted into other and to establish equilibrium, it takes a while. So that is a talk on tautomerism. Finally, I have a question. Can this compound show tautomerism? It is called acetyl acetone. Can you show tautomerism?
No.
No, sir.
It has a sp2 hybridized atom making double bonds. Can you see? Two such fellows are there. Yes? And it has sp3 hybridized atoms having hydrogen. There are three such fellows. Why it should not show tautomerism, sir? In fact, it shows tautomerism excellently, very well. I don't know, you have missed the point. What is your requirement for tautomerism to exist? Hello. What is your requirement for tautomerism to exist? Huh?
Two sp2 hybridized atom and one sp3 hybridized atom.
It is sp3 hybridized carbon having hydrogens. sp3 hybridized carbon having hydrogens. Definitely they can show tautomerism. Yes or no? How would tautomeric form appear? Let us try to write there. Can you write it tautomer? If you want, you can write it as CH3 C double CH. Both are same. Acetyl acetone. It has a symbol AC. Now, this hydrogen will go over here because the pi electrons come here. And you get a double bond here. No change here. It is called enol form. Can you see it? I am drawing it again. I am drawing it again for you. Sir, this oxygen is taking this hydrogen, sir. And the bond connecting carbon and hydrogen has come here. So it is your keto form converted to enol form. En because double bond, ol because alcohol. It is enol. It is keto. Keto enol tautomerism. What is the problem? What is the big deal? You should examine the molecule whether it has a double bonds. The doubly bonded atoms have a neighboring carbon that is making only hydrogens. It can show tautomerism. So anyway, don't worry. Tautomerism is not there in the textbook. Let's not waste our time. Next. Let's clear this mess. Let's clear this mess. Yes, sir. Now, today we are going to look at something different, stereoisomerism. Stereo means spatial arrangement. These isomers arise due to variation in the spatial arrangement of groups around carbon. Notice there is no change in bonding sequence. Let us look at the stereoisomerism. It is two types, conformational isomerism, configurational isomerism. Configurational isomerism, there are two types, geometric isomerism, optical isomerism. Now we are looking at conformational isomerism. Sir, what is this molecule, sir? Hello? What is this? What is this?
Ethane.
Ethane. Now let us do one thing. This is a carbon, this is a carbon. Now this carbon is linked to three hydrogens. Well, let us use some blue color for a change. Now this carbon is locked to three hydrogens. Let us use red color. Let us clear it and write again. Start with red color. Put to blue color. Again, let us take another molecule. Start with red color. Sir, one point here is there is a carbon locked to a carbon. Each carbon has 3 hydrogens. Now you are looking from here. This is your eye. When you are looking here, this hydrogen you are seeing, and they are behind you. Can you see the second hydrogen when you are looking from this side? Hello. The hydrogen number 1 will mask the hydrogen number 2. Hydrogen number 3 will mask the hydrogen number 4. Hydrogen number 5 will mask the hydrogen number 6. Can you feel it? Yes or no?
Yes.
Hello. Can you
Yes,
see
sir.
this is a 3D? See, whenever you are drawing what is happening in a 3-dimensional space on a 2-dimensional board, it is called projection. A projector is an instrument that captures pictures in a 3-dimensional space and focus on a 2-dimensional board or on a screen. Projector is what it is doing, sir? Projector captures something in 3 dimensions and puts on 2 dimensions. So this way of writing ethane is called Newman projection. Here when you are looking like this, the first set of hydrogens are not allowing you to see the second set of hydrogens on next carbon. Yes? Yes or no?
Yes,
Yes,
sir.
sir.
Now, if whenever 2 carbons are linked by a single bond, the CC bond can rotate. Like if you have a plank like this, and if you have another plank like this, both are connected by a nail which is loosely bound, you can rotate the second plank. Can you rotate or not? Hello?
Yes, sir. Yes, sir.
Can you rotate? When you are rotating, suppose you rotate by 60 degrees, then what happens is, the second set of hydrogens go like this. Now this hydrogen is not masking anything there. This hydrogen is not masking anything there. This hydrogen is not masking anything there. Notice that here both hydrogens are as close as possible. Here these hydrogens are as far away as possible. Can you see that really? Hello?
Yes, sir. We are able to see.
Whenever a CC bond is rotating, one type of configuration where hydrogens on first carbon are masking the hydrogens of second carbon will tilt their positions, and they go to a situation where one hydrogen is as far away as possible to the second carbon's hydrogen. The first form is called eclipsed form. The second one is called staggered form. Like that, if you keep on rotating, there can be different possible orientations. How many orientations I can have? If you rotate by 360 degrees, there can be infinite orientations. The different formats of molecule that arise due to free CC rotation are called conformers. Conformers are possible only when 2 atoms are linked through single bond. Suppose, sir, if I put another nail here, now can you rotate? Can you rotate? Hello?
Sir. No, sir.
Can you rotate if I put second nail?
Not possible, sir.
The second nail is opposing the moment, or it is restricting the rotation. Therefore, the conformational isomerism is not allowed if 2 carbons are linked by a double bond, or if they are restricted to move about due to a cyclic system. Therefore, the conformers arise due to free rotation of CC bond. There can be infinite number of conformers ethane can have. The conformers can be looked at by using Newman projection formula. We call it as Sawhorse projection. I'm sorry, Sawhorse. We can also use Newman projection. Newman projection is slightly different. In Newman projection, what you do is, you say this is your first carbon, these are the 3 hydrogens. And now, this is the second carbon, these are the 3 hydrogens. Here the hydrogens of first carbon are masking the hydrogens of second carbon. It is called as eclipsed form. And this is another Newman projection where hydrogens of first carbon are as far away as possible to the hydrogens of second carbon. This is called staggered. This is called eclipse. Therefore, one can explain the different conformers either using a Sawhorse representation or Newman representation. By projection, we mean the way of writing a 3D molecule on a 2D space. And of infinite conformers, 2 are extremely important. One is called eclipsed, the other one is called staggered. In eclipsed form, the repulsions between the electrons of like atoms are serious. Therefore, eclipsed form is less stable, staggered form is more stable. In the staggered form, the hydrogens are very far away, repulsions are least. Eclipsed form is less stable, staggered form is more stable. But the energy difference between them is really less than some 20 kilojoules. Therefore, they keep on getting interconverted and they can never be separated. The infinite number of different spatial orientations that can be observed for a molecule where the different carbons are linked by single bond are called conformers. Of all conformers, 2 are extremely important. Since the energy difference between them is very low, they cannot be separated. The conformational isomerism becomes impossible if the 2 carbons are locked by a double bond where the free rotation is hindered. Also, cyclic systems will hinder the free rotation of CC bond. The conformational isomerism becomes important for some molecules like butane, ethane 1,2-diol, etc. We will be discussing about that later on in senior intern. At the moment, we will not bother much about it. It is not given in your textbook more than this. If there is time, I want to talk more on this because in IIT mains they are asking questions on this. Now I gave an introduction. What is conformational isomerism? Did you understand what it is, sir? Hello?
Yes, sir.
Yes.
Notice the conformational isomerism is a type of stereoisomerism. Both these anti and bi are not differing in the bonding sequence. They are differing only in spatial arrangement of groups. Yes, sir? Can you see it?
Yes, sir.
Now I am going ahead.
Yes, sir, we can see.
Sir, the second type of stereoisomers are called geometric isomers. Sir, what happens if 2 carbons are linked by a double bond and this carbon is having, say, Cl and methyl? This carbon is also having Cl and methyl. What is the name of this compound, sir? What is the name of this compound?
Dichloroethane.
1, 2, 3, 4. 2,3-dichloro-2-butene. Now I will write this. Let us use black color. C-double-bond-C, chloro, methyl. C-double-bond-C, methyl. Do you think 1 and 2 are same? Do you think 1 and 2 are same? Yes or no? Hello.
No.
Yes.
Here, two CLs are very close. Here, two CLs are very far. You can't rotate it. The double bond will not allow the CC rotation. This molecule and this molecule are different. They have different melting point, different boiling point, different chemical properties, different physical properties, different stabilities. Out of 1 and 2, which one you think is more stable, sir?
Second one.
Out of 1 and 2, which is more stable, you think, sir? 2?
Two.
Why
Two.
2?
One.
Why
One.
2?
Because
One
of
sir.
the expulsion.
Definitely 2 is more stable because the repulsion between like groups is minimum. They are as far away as possible. In one, bulkier methyl groups are very close and they are likely to repel. This is called cis 2,3-dichloro-2-butene. It is called trans 2,3-dichloro-2-butene. Generally, trans form is thermally stable. Generally, trans form has higher melting point. Generally, trans form on combustion gives less heat of combustion. More stable a compound, less is heat of combustion. The cis and trans isomers arise if and only if there is a restricted CC rotation, if and only if it is like CAB double bond CAB. On both carbons, if A's and B's are coming on the similar side, and that is called cis. If A's on adjacent carbons are on opposite side, that is called trans. Are we very clear? Sir, can this compound show geometrical isomerism? Can this show geometrical isomerism? Auntie, boy, which can show geometrical isomerism? Chutney. In ABC, which can show geometrical isomerism? Only A, only B, only C, all ABC.
Only B.
To show geometrical isomerism, C double bond C must be linked to AB. AB. If it is like CA2 double bond CAB, it can't show geometrical isomerism. If it is like CA2 double bond CA2, nonsense, it can't show. If it is like CAB double bond CXY, then also it can show geometrical isomerism. Generally, if same groups are on the same side, we call it as cis. If they are on the opposite side, we call it as trans. Sir, this acid, can you name this acid? Now I want to draw. Can you name this acid, sir? COOH. COOH. H. Can you name this acid, sir? Hello, can you name this acid?
No.
Bute 2 in dioic acid.
Bute 2 in dioic acid. B is bute 2 in dioic acid. Both are same. But here both COOH are on the same side. I call it as cis bute 2 in dioic acid. I call it as trans bute 2 in dioic acid. Which is stable means B. B is having a common name called fumaric acid. A is called malic acid. These are common names. Fumaric acid is trans isomer. Foot means fumaric acid is trans. Malic acid is cis, less stable. So many compounds where CC rotation is restricted due to a double bond or due to ring can show geometrical isomerism. If you have a compound like this, it is 1,2,1,4 dichlorocyclohexane. If both CLs are on the same side, it is called cis. If one is below the ring, one is above the ring, it is called trans. You can't convert one to the other. So geometrical isomers arise due to restricted rotation. The rotation of CC can be restricted through a double bond or through a ring. All molecules which have double bond may not show geometrical isomerism. It should be like CAB double bond CAB. Or it can be even like CAB double bond CXY. Let us take a case. If I have CClBr double bond CFI, what type of isomer it is? Is it cis or trans? To say cis and trans, I say cis isomer have similar groups on same side. This side there should be similar group. But here nothing is similar. If all substituents linked to C double bond C are different, then what I do is I decide the seniority or priority. According to my seniority rule, more atomic number, more priority. So let us take this carbon one. On the ClBr, its atomic number is less than the atomic number of Br. So I assign more seniority to bromine and less seniority to Cl. Similarly, in F and iodine, more atomic number is there for iodine. Therefore, iodine gets more seniority than fluorine. On the C double bond C carbons, the adjacent positions are occupied by high priority groups only. Then that is called Z isomer. There is another classification called E and Z classification. If high priority groups are on the same side, it is called Z isomer. Zusammen, German word. If high priority groups are on opposite sides, it is called E isomer. This is called EZ classification. All the details are there in your MS College chemistry material. You please open and study about stereoisomerism. I try to give you many more new ideas on this subject. Today we started our discussion on isomerism. We have seen some structural isomers. Then we have gone to stereoisomerism. Then you looked at conformational isomerism. Then you have gone to geometrical isomerism. Any doubts? Hello? Hello?
Yes, sir.
Any doubts? Hello? If you don't speak, I will wait. I can't wait infinitely. You do one thing. I am not able to hear any noise from any of you. I don't know whether you are there or not there. Are you there?
Yes, sir, we are.
Yes, yes.
Sorry, geometric isomer, generally trans isomer is very stable. It has higher melting point. If you burn it, it gives less heat of combustion. More stable a compound, less is heat of combustion.
Okay.
To show geometrical isomerism, the doubly bonded atoms must be locked to different groups.